Hi everyone, it's Mr. H here. And in this video we're going to talk about solving equations using the KRAI method. We're going to solve the following three equations, and you can skip ahead if you want more difficult one. We're going to start with a fairly straightforward one, then one without any brackets, and then end with one with brackets. So what does the KRAI method mean? Well, it's an acronym. It stands for KRAI, which stands for kill the fraction, rainbow, which is another way of saying the distributive property. Many times students don't, as they're learning this, don't remember the name of the distributive property, but it's easy to remember the curve of the rainbow. All like terms together, and then I stands for isolate the variable. So let's go ahead and solve the first equation using this method. So the first question says solve the following 2x minus 5 equals 7. Well, we're going to go ahead and see if there's a fraction. There's no fraction, so there's no fraction to kill. There's no rainbow or distributive property needed because we have no brackets. And there's only all like terms getting together and isolating the variable. Well, like terms are this term and that term. So they're the only terms without an x in them. There's only one x term, so that doesn't need to be combined with anything. So what we're going to do to combine those is I'm going to add 5 to both sides. So if I add 5 to this side and add 5 to that side, then negative 5 and positive 5 cancels off the left side. And I'm left with 2x equals 7 plus 5 gives me 12. So what I've done is I've got all like terms together. I already mentioned that there's no fractions and there's no distributive property needed, so we've done those. The last thing to do now is isolate the variable. So we isolate the variable by dividing by the number in front of the x. So if I divide by 2, there we go. 2 divided by 2 cancels out to become 1, so we just get x equals 12 over 2, which is 6. And so now we've isolated the variable. So for this one, all we really had to do was all the like terms together and isolate the variable. The next question we're going to look at is kill the fraction. It's going to be part of it. And then the last one is also going to include the rainbow step or the distributive property. So here's the second question. So you notice here we've got a fraction. And so we're going to have to do this first step of killing the fraction right there. How do we do that? Well, the way we do that is we find a lowest common denominator. Because there's only one denominator here, the lowest common denominator, often called the LCD, that stands for the lowest common denominator, is just 5. There's no real thinking here that we need to do that. Here, the lowest common denominator is 5. And so what we're going to do is we're going to multiply both sides by the lowest common denominator. So I'm going to multiply one side of it by 5. I'm just going to rewrite it here, 3x minus 4 over 5. And then on the other side, I'm going to multiply that by 5 as well. And so what happens here, and you might be a little mystified of why the 5 is going to cancel initially, is the 5 is going to cancel out with the 1 below it. But the reason that happens is actually because the order of multiplication and division doesn't matter. So I could multiply the 5 by the 3x minus 4 and then divide all that by 5. Or I could go 5 divided by 5 and then multiply it by 3x minus 4. We can swap the order of multiplication and division. That's totally allowed. So another way to write this would actually be 5 over 5 times 3x minus 4 equals 5 times 7. And so now you can clearly see that that cancels out. So 5 over 5 gives us 1. So we get 1 times 3x minus 4. And I'll leave that as 1 for now, just so you can see how the rainbow rule works here in a minute. And then 5 times 7 is 35. Now you'll notice here that if I've killed the fraction, so done, no more fractions left, and that often alleviates a lot of the stress that students have on these types of questions. So now that that's gone, that should be a lot easier. If this wasn't 1, then it's going to be multiplied by everything that follows. But if it is 1, it's not changing anything, but it's still being multiplied by everything that follows, isn't it? So it's not really a step that's needed, but there you can see the rainbow rule working here. It's 1 times 3x, 1 times negative 4. So we get 3x minus 4 equals 35. So we've done the kill the fraction, we've done the rainbow rule, which wasn't really applicable here, but just to show you how it works. Now we need to get all the like terms together. The only terms that are not together are those two. So I'm going to add 4 to both sides. Whatever you do to one side, you have to do to the other. It's going to cancel off there. So we get 3x equals 35 plus 4 is 39. The very last step now is isolating the variable. We're going to divide by 3. and we get x equals 39 divided by 3. 30 divided by 3 is 10. 9 divided by 3 is 3. So 13 is the solution for that equation. All right, let's look at this last example. We're going to put all the pieces together here and see how it works out. All right, so the first thing to do is try to kill the fraction. Well, we kill the fraction by looking at the lowest common denominator. We have numbers of 5 and 3. And if we look at multiples of those, some of you will probably see this right away, the lowest common multiple of these two things would actually be 15. Just list them here. You can see 15 is the lowest common multiple. So that means the lowest common denominator would be 15. Well, what do we do with that lowest common denominator? We're actually going to multiply both sides by that lowest common denominator. So I'm going to multiply 15 times 2 times 3x plus 4 all over 5. And then I'm going to multiply 15 times 6 times 2x minus 1 all over 3. Now, it might look like I'm making more of a mess, but remember, the order of multiplication and division doesn't matter. So you might be comfortable just canceling out the 15 and the 5 here and recognizing that's 3 over 1. But if not, let me write that step out for you quickly here. This is 15 over 5 times 2 times 3x plus 4 is equal to 15 over 3 times 6 times 2x minus 1. All right, this gives me 3, is 15 divided by 5 is 3, times 2 times 3x plus 4. 15 divided by 3 is 5, times 6 times 2x minus 1. And so now one of the mistakes I see students make sometimes is they go 3 times 2, and then they also multiply 3 times the 3x. Don't get confused by that, right? We're only multiplying by the 3 once. And so what we're going to do first is we're going to multiply 3 times 2, going to get that number, and then write that out in front of the binomial. A binomial is just something that has 2 terms in it. So the 3x plus 4 is a binomial. So 3 times 2 is 6. 6 times 3x plus 4. 5 times 6 is 30 times 2x minus 1. And so now it looks pretty good, right? We've killed the fraction. We're ready to do this rainbow, or this distributive property now. And so we're going to go 6 times 3x and 6 times 4. We're going to do 30 times 2x and 30 times negative 1. So 6 times 3x is 18x. The 6 times 4 is 24. 30 times 2x is 60x. 30 times negative 1 is minus 30. If you're not really quick with those multiplication, it would be worth going back and actually reviewing those and making sure you can go up to 12 times 12 in your head. I know this sounds silly, but it's actually the students that do the best that I've seen are ones that know their multiplication tables up to 12 times 12. Really, it's that simple to do well in high school math, to have that really good grasp and foundation. All right, so we've killed a fraction. We've done the rainbow or the distributive property. All like terms together now. How do we get all the like terms together? Well, there's 2 ways to do this. We could bring all the x's to the left and all the non-x's to the right. Or we could bring all the x's to the right and all the non-x's to the left. Here, I'm actually going to bring the x's to the right. And the reason for that is I can see that it's going to keep them positive. And if I can keep it positive, generally that leads to less mistakes. So what I'm going to do is I'm going to subtract 18x from both sides. If I subtract it from that side, it cancels out. And if I subtract it from this side, it's going to become a positive because 60 minus 18x is going to give me 42x. I'm also going to do that for the other terms now. I've got the x's together. Now let's get the non-x's together. So if I've got the x's on the right, let's bring the non-x's to the left. So I'm going to add 30 to both sides. They're going to cancel off the right. And on the left, I'm going to get 54. And so now I've got all the like terms together. Awesome. The last step now is isolating the variable. And here, everything's positive, so it works out really nicely. By the way, if you had brought the x's to the left, you would have gotten negative 42x is negative 54. And hopefully you can see that ends up to be the same thing. Because when we divide it out, we get rid of the negatives. Negative divided by negative makes it positive. So if you'd done that, you would have gotten that. So 54 equals 42x. I'm going to divide by 42. So 42 divided by 42 cancels out to give me 1. So it's just x. 54 over 42, if we divide both of those by 2, I'm just going to, I guess more technically I read it like this, divide by 2, divide by 2. Half of 54 is 27, and half of 42 is 21. So I believe it simplifies to that. Now that might not be very satisfying for you. You might think, oh man, like it would be really nice if that was a whole number. But the whole reality of life is that we rarely get whole numbers. If you have a teacher who's teaching you something, you might want to ask them, are most of the answers going to be whole numbers? They might indicate that right from the start. And if they do, then that's a good indication of whether or not you got it right or wrong. But if they don't tell you one way or another, there's definitely times you're going to get fractions. Last comment here, and that is this. There's video on the left. You can check that video out. That's going to give you why this works. Because you might wonder why that works, and it's really good to understand why it works. The video on the right is going to show you how you can check your answer and know for sure when you walk out of that test on solving equations if you know you're right or not. So check those out. Encourage you to continue and subscribe to learn more.